So please join me welcoming Alexander, the head of SRE for Business Ops at Jumia.
Hi everyone, how are you doing? So, just to fill the crowd, how many of you are SREs or DevOps or sysadmins, however they call us nowadays? One? Those two are lying, they're liars. Yeah. Those two are on my team, so that's a tough crowd. So today I'm gonna do a little different story than my colleagues. I've been here for 8 months, so I don't have the most to tell you regarding the past of Jumia, but I can tell you about the present and how we're building and how we're scaling and how we're making new tools to scale up the beautiful apps that Bruno and Jose presented. So, moving on to the agenda, I'll present you with the challenge that we had when I first joined, because then to give you some context, Jumia grew organically, so we have many products being released over the years. The infrastructure stayed more or less the same, and basically we had a pretty old way of doing things, and we had to speed it up to the future. Yeah, sorry, it's my first time speaking to a microphone, so that's good to know. So basically, we had a big challenge to bring the infrastructure to the future. We actually needed to go back to the whiteboard and develop a new infrastructure architecture. We've followed the immutable infrastructure approach. I will explain in detail why. And we also knew and understood that for immutable infrastructure, we will need infrastructure as code and how we implemented it. And then I will tell you a little bit what's the plan for Jumia infrastructure in the future. So let's get started, the challenge. So we had multiple pain points because we grew organically, and that included doing a lot of manual operations. Most of our infrastructure scaling up and most of our infrastructure configuration updates were being done manually. We could code them because we were using tools like Ansible, but we still needed to apply them manually, which was a big deal. We had redundant tooling. For example, we had Salt SSH, we had Ansible doing the same stuff for different tools, for different products, and we wanted to end that because we wanted to get to a centralized code base. We had no integrity between environments, so because we used immutable infrastructure, we couldn't make sure that the staging configurations were the same for production configurations, and there was a high risk of failing a deployment because of missing configurations. We had a fractured code base because we had lots of deployment scripts across multiple repos. That impacted the time to production of new microservices because we had to code like 3 different repos and between 3 different code bases. And we were feeling that we were impacting developers' freedom. So when we went back to the board, we go back to the fundamentals. What did we want to preserve? We knew we were good at scaling, and we knew we were good at reliability. So we had high resiliency, so infrastructure almost never failed. But we still wanted to gain something. We wanted to gain integrity between environments and between code bases. We wanted versioning, so we wanted to be able to understand what version of an application was built on top of which version of infrastructure. And we wanted agility. We wanted to deploy faster and allow the devs to deploy faster. So what do we needed? We needed infrastructure versioning. We need tooling scopes. We need to understand what tools actually do for us and where they are good at. Okay? We needed a new infrastructure, and that included new architecture and new deployment pipelines, both for applications and both for infrastructure. We wanted a roadmap for our tooling because everyone that works as a DevOps knows that stack is huge. And we want to know what the apps are good doing and what we will do with them in the future, or if they need to be replaced or not. And we want no manual interventions, so we want to automate everything that we have. Okay, so for me, the job of a DevOps or an SRE is to automate ourselves out of jobs. Okay, so infrastructure architecture. That's actually the infrastructure we got on the board. We did it from scratch. And what we have on our production environment is basically, in terms of application layering, we have an application cluster. We use Kubernetes for orchestration. So we have 3 clusters And we divide those clusters through countries. So we have separation, physical separation between countries. We have 3 of them because our biggest ones are Egypt, of course, Nigeria, and then we have a 3rd cluster for all the other countries that we have. This will increase in the future, actually. But what we use is, because we are around like 10% of SREs for developers, we needed something that didn't give us a lot of time managing. So we went to shared services. That's why we use AKS as our master layer that controls the whole clusters. And then we have EC2s. Okay? As every geeks, we name our applications like Super Mario. So we have Yoshi, we have Koopa, we have Super Mario. Don't blame for that. I would go the different kind of games, but well, that's a personal choice. And then we have, outside of the applicational cluster, we have Kafka to support this because we have an event-driven architecture, and we have 2 nodes per each availability zone. So we are very resilient unless a region fails, which we're working on at the moment. And we have EC2s for our ELK stack, so for our logging, for our applications, and that's also through 3 availability zones. So inside of that applicational cluster, that's the Kubernetes logic that we got to was this one. So pretty much we approach this in the way that we could scale it in terms of future products and for future countries. So we develop a logical separation between namespaces. So we have, every country has a specific namespace, although they run on the inside the same cluster. And what we have is a conch for our API gateway. It does domain restriction, it does API authentication. Then we have an Nginx ingress controller for routing traffic. Then we have that traffic is routed to our services. Every service is deployed together with the application. Then we have our pods. They are not actually just pods, they are full deployments. Okay, and they have the Super Mario, the Koopas, the Yoshi, 2 additional ones, Bowser and Princess. Yes, they're actually our names. And we have an HPA and an autoscaler that do the autoscaling layer. Okay, and this works for every namespace. And if we want another country, we just deploy a new namespace with the name of the country. And then we have a common namespace that will allow us to, like, applications that work that are the same for every country. They are used by every namespace that we have here, and they're inside the common namespace. Okay, so this is our data layer. For our data layer, we have RDSs. We use shared services because maintaining database services is a full-time job. And we use 2 flavors. We use Postgres, MySQL. We have a master and a replica. And they are multi-AZ as well. So they are replicated across different availability zones in case we have an availability zone failing. Then we have also for Memcache, we have Elasticache, as well as managed services. And we have EC2s for our Mongo and our Couchbase clusters. Okay. Then we have our monitoring environment, because if we're going to rebuild all the infrastructure and we're going to put everything on Kubernetes, or we need to revamp our monitoring. How did we revamp our monitoring? We choose this stack. It's basically a new cluster, just a central cluster that manages and collects metrics for every application that we have on JumiaPay. If any of you work with Prometheus, Prometheus has a problem, which is replication and resilience. So Prometheus basically doesn't have a system of replicating itself or handling a cluster, or a clustering system. So we put Thanos on top that does metric duplication, it does cold storage, it does lots of things in terms of, it solves lots of things for us to run multiple Prometheus and have like the same metrics, and the metrics are cataloged and fully tagged. And then we have Grafana for beautiful dashboards that we do. And we have our beautiful butler on an EC2 as well. That is going to be changed because Jenkins is a pretty old implementation, but we have a beautiful library that does everything for us in terms of deployments, in terms of configurations, in terms of injecting environment variables. So we have a lot of legacy code that we want to preserve, so we will not change it at least this year or the next one. So we chose immutable infrastructure to deploy this. Why? Because at first we were following a snowflake approach, where basically we would code, we use Packer, so we would code the server image, we'll package that image, we'll provision a server, and then that server will stay like this until we'll apply a configuration change. And then we'll apply another configuration change on top of that, and that was all versioned and coded, but the Ansible didn't reflect the code that was before. So we were increasing in terms of changes, and we didn't know which application ran on each version of the application. So we decided to change this, and for this we followed the Phoenix approach, where basically we destroy every infrastructure on the old version, and we implement a new one, and there's only one change. This will allow us to understand which version of application we're running, and we will not have to worry about manual interventions because we just have to do a new deployment and the configurations will be overridden. So this is how our flow looked like in a Snowflake approach. We use our flavor of editors, we coded, we built the image by Packer, we planned it with Terraform, we applied it, then we applied configurations on Ansible, then we applied configurations again, and then we had the logging, and we go ad eternum with this. On the Phoenix flow, we just do the same, but we have more steps, and we have beta testing. So we have the flavor again, we build the image as Packer, we plan it with Terraform, we have CI/CD with Atlantis, and that's basically triggered by GitOps. Then we deploy after planning, if planning goes well, if it has 2 reviews, 2 CRs, we deploy it. Then we test it with a suite. Basically, it's our Jenkins that's triggering Python that's doing a lot of running our code base in terms of bash scripting and testing if the nodes connected well to the Kubernetes cluster, how's the health every application is pinging, if they are running, if the ports are always open, if there was no misconfiguration. And then after that, we basically cordon every node that we have on the cluster. After we cordon, we drain them. It passes into the new version of the infrastructure. And then after, there's also Jenkins is waiting for that to happen. When that happens, it tests again. And then if it goes well, it triggers Terraform to destroy it. And then the old version is history. And then we have the new production version. Everything we're monitoring through our logging and monitoring and alerting. So we have a full suite of alerts that is triggered on these cases. We know when the deployment happens. We know when the infrastructure is being tested, if the test is passed or not, if they were deployed correctly, if there is an application that's not running or if it's running well. And we actually know when it's destroyed, and so we can roll back quickly if we have some issue. So what did we gain from this? We had no configuration drift between the code base or manual actions. We got a consistent staging and production environments. So because this flow is followed through dev, staging, and production, we ensure that the version that we have on production in staging is the same that we have on production, and so on and so forth. We could easily vertical scale, which basically, if we were to deploy a new node group of Kubernetes, what tend to happen, we couldn't increase its size easily, because we needed not only change the Terraform code, we need to apply new Ansible scripts that could not, maybe they're not very good tuned for the new size of the machine. This way we can just code it, put it on staging, see if they're tuned or not, and then deploy that version on production. We can have simple rollback and recovery processes. So if we see that the problem resides on the hardware, or if we have some issue with the hardware configurations, we can just roll it back as doing an application deployment. And we basically know if every time we know if the servers are in a good state, and you have fewer deployment failures because of infrastructure. So this is all possible because we implemented the infrastructure as code. We wanted to gain modularity, so we wanted to reuse code. So we wanted the code to be reusable by both staging and production, both for time-consuming tasks and also for reliability of code. So we know that the same code is deployed across staging and production. We want multi-environment and standardization. This basically, it's what we wanted with modularity, but for the future we want to template everything because we want to automate everything. If we found a common denominator, I have the same problem as Jose. This is a hard word. Between every environment, we get standardized across not only JumiaPay, but across all products of Jumia. We want a clear structure of code because if you work with Terraform before, you know that getting lost in modules, getting lost in configurations is a very easy task. So you want a clear structure between what resources, what modules are of which resources, and we wanted a clear structure in our code that reflected this. And we wanted the updated features because we were doing Terraform in 0.10, and we upgraded it from 0.10 to 1 point something. And we got loops, we got workspaces, we got many updated features. So we did a code-based refactoring. So before we had a Terraform for production, a Terraform for staging, and we implemented each one of them in production and the other one in staging. Then we moved into that one where we code modules, we have workspaces, okay? They're two different repos, and basically the modules are used for staging and used for production. And so that way we have the same code for each one of them. We don't have declarative modules anymore. We can loop, if we want to create 3 clusters, we don't necessarily need to declare the 3 clusters, we can just loop it. And we then deploy them into the specific environments. Okay, so this one was the hardest part and the biggest pain point. We had around 40 scripts that did the deployments. We had the Docker image inside every application. And we have the application configuration files inside the same repo. And that all was consumed by Jenkins to deploy it into production. Okay. What we did, we changed from Bash scripting into Elm, which is a more mature solution and gives us a fast rollback process in terms of application deployment. So every application and every infrastructure, every application has an infrastructure folder, if you want to look at it that way, that tells the cluster how it wants to be deployed, how much resources it needs, how it wants to scale, how many replicas it has, if it has to do something on Kafka or not, like creating topics. And that's our template and our shard for Helm. Then we have the build, the Docker image that Helm uses to build the application. And then we have the application configuration files that tell Helm what to inject and not to inject. And that gets deployed into production. So this has basically been the last 8 months. What do we really want to do? This last 8 months was to refactor everything that we had. So what we want to do now is get to the cool stuff. We want active multi-region. So it means that if a region fails on AWS, please not for a year. We want another infrastructure ready and another infrastructure serving the applications as well and load balancing it through multiple regions, so we don't have, it's active, so the other one will still doing active work. And we have service mesh, so we can modulate traffic and allow for A/B tests, because as Bruno told you, it's being done by software. We want that to be done on the hardware layer. And that will facilitate us to do canary deployments, because right now we can do a sort of canary deployment because we deploy a smaller country and then a bigger country and then a more bigger country, and until we get to the biggest countries that we have. If we take the traffic on Jumi as a whole, you can get a canary deployment. But we can say at the moment, like, let's deploy this new version of infrastructure for new version of an application for 10% of Jumia, of Egypt, for example. With service mesh, we can implement that, and we can start doing that. We want chaos engineering, so there's always, if we have to assume that there's always a possibility that we have a bug on the code, and in an event-driven architecture, what tends to happen is we can't predict every scenario. So chaos engineering is something that we want to implement, so we want to start breaking the staging environment voluntarily, both as in staging and production, and see what happens. Okay, first in staging, of course, as always. But let's start, see what happens, see what bugs arise, and then we can tell the developers, this happened, that happened, we need to change this and that and that and that. And then, because the way I see SREs and the DevOps world going is every developer shouldn't be pending or be hostage of an SRE. So what we want to do in the end, that's why we follow this and this big refactor, and we want to implement these tools, is because in the future we want an internal development platform. What it means that if a developer has a tight sprint, he needs to build a microservice, it has 3 weeks, he can't wait for us to do the Helm charts, do the pipelines and stuff. We want them to go to the code and just say, okay, I want a new application, this is the framework I want to use, and that builds everything automatically. And that's it. So please go slow on the questions, because as you saw, I don't understand much of this stuff.
By the internal development platform that you will share a single code base for all the pipelines on Jenkins, or
By internal development platform, I mean, imagine if you're a developer, and there are lots of things that you need. You need a development environment, a staging environment, and a production environment. You need pipelines to deploy those applications, and you need all the dependencies that you need for a Docker file to build your application. If I give you a client tool that you just say, please create the new service called X, the repository name will be this one, and I want to deploy it in development and staging, and that the tool does everything for you. Creates your repo, creates all the dependencies, all the Helm charts, creates the Kubernetes namespaces, creates the deployments for your application. It's basically a full suite for developers to use.
full stack app, you mean, right? A full stack app, you mean, or a web app?
Yeah. Basically an API that you have a client interface to interface with. Yeah.
Thanks.
Yeah. Go ahead.
You mentioned the multi-region roadmap. So
Yeah.
Is it good from an infrastructure point to go also to a multi-vendor roadmap? So for example, you are hosting Mongo. Why do I go for Mongo as on my EC2 cluster rather than going to Atlas, for example, and take an off-the-shelf solution with GCP or something like this? So that's like kind of the hard questions that mostly not Jumia but smaller companies need to answer every now and then. Should we go to the full custom solutions, or should we go to the off-the-shelf, which will force us to the multi-region sometimes, and it might also force us to the multi-vendor solution? I have another question.
Okay. Okay. If I understood it correctly, you asked two questions there. Why we should go multi-region instead of going multi-vendor? Yeah. Or you asked if we should go multi-region and also multi-vendor.
So, should we or shouldn't we go multi-region and totally on for the multi-region?
Mm-hmm.
Could happen in the region I'm depending on, but should I also go to the multi-vendor or not? And when should I go to the off-the-shelf, and when should
Okay. So basically, and there is no better cloud at the moment, at least in shared service, in managed services, as AWS. So it all depends on the model that you have of development or your teams of development. If you have an SRE per team, you could go to basically any cloud that you want, because not depending on managed services, because that SRE has time to do everything. Okay. So if you have the SRE model that we followed by Google, what tends to happen is we have a bottleneck on SREs, on scale. And what we do is basically everything that takes a full-time job to manage, we go to a managed service. That's why AWS is the best one for me right now. If you're going AWS, and if you're using infrastructure, it's called immutable infrastructure, you know that Terraform, or the provisioning infrastructure, Terraform they sell it as cloud agnostic, and it is, because it has providers for different clouds, but you still have to code it. And one infrastructure in GCP is not the same infrastructure as AWS, because they have different managed services. So if you're going AWS, you should go multi-region, because I never saw it happen, a full region fail, but you should do it, because it's not that complicated to do. If you want to go multi-provider, you can go as but that will have a lot of overhead costs. Okay. But yeah, I hope I answered your question.
I might add a small question.
Yeah.
So you mentioned the Kai's engineering. So, and also I assume the two previous sessions, we mentioned that we are depending on microservices. So combining chaos engineering and microservices, you can also go to, how can I say, to a paradigm where you can test all your services collectively and test if you have a failure point, what are the negative effects in other applications or not. So is this also mentioned within the chaos engineering, or is it only from the infrastructure point of view?
No, no, no. It's from the chaos engineering is mostly for application and the development point of view. So basically, if you're following event driven, you can predict the bugs on your application, or you can control for it. But what you can never do is predict how your applications will interact with each other in the case of a critical failure of a node in Kubernetes. So what chaos engineering gives you is you do it like an immune system. You do it little by little until you get fully immunized. Okay. So basically, chaos engineering is more for application development than for infrastructure. Because for infrastructure, we have AWS on our Macs that's doing it for us. No worries.
Can you hear me?
Yeah.
Okay, the first one is, do you have a set of rules for instrumentation of code from the software engineering side?
Mm-hmm.
And the other one is, how do you manage access for the software engineering teams to gain access to the infrastructure?
Okay. For segmentation faults, we do have controls, but they are way above in the layer. So we use Helm. So if any application gives a segmentation fault, Kubernetes handles that for you. Instrumentation fault.
Can you hear me now?
Yeah.
Okay, I'm saying, do you have a set of rules from the DevOps side to the software engineering side to instrument their code, like adding metrics, adding logs, adding tracing, all of this? And the other question is, how do you gain access or give access to engineers for the infrastructure who have access to deploy their code, monitor their code, and do like continuous deployment of the code and monitor it? Do you do everything yourself, or do you delegate this to software engineers?
Yeah, in terms of the second question, I got it. What do you mean by instrumentation fault in the first question?
Instrumentation of code is like helping the engineers to add metrics for their code, how to add logs in their code, what format should they add code, and also like if they want to do tracing and like trace of the request between the microservices, since this pretty complex architecture, so they might need some kind of tracing of the request from the first microservice to the last microservice.
Yeah, we do. We use an APM, so that's New Relic. Yeah, so we use an APM, we use New Relic, where they get all the metrics that they want on the applicational level. For the infrastructure level, in terms of resource consumption, what's failing, what's not, if they can reach another service, if not, we use Alert Manager from Prometheus, and that's our devs build the exporters themselves, and they export the metrics that they want. Our clusters have service discovery, so every exporter that they do, Prometheus can collect them on the fly, okay? And it exposes them on Grafana, and they can see those metrics flowing in. They can look at it on Thanos, and also they can build dashboards themselves to follow those errors or follow that. In terms of the second question, access to we don't at the moment. So what we do is, at the moment, we give them Grafana dashboards, so they can look at how the application is behaving, the metrics. But in terms of cluster access, in terms of a dashboard where they see the pods running, they can restart them, they can kill the deployment, deploy again. We're working on a dashboard for that, but at the moment we still don't have it.
I have a question. Here? Yes? So,
yeah.
Maybe about general question about the cloud system that something else. I'm not talking about AWS only, but about how to optimize the code, like doing the.
So if we want to apply the cost saving and optimize, whenever we have scale, horizontal scale or vertical scale, at that point we have like a very big bill, and we want to optimize a way or another. But at the end, we need to optimize the balance. So do we have like such tools, or try to follow something?
Yeah, we do. We actually have a problem with that at the moment. that we're trying to solve is when you go Kubernetes, you have horizontal pod auto scaling and you have auto scaling in the cluster auto scaling. You lose the horizontal scaling, so you can track how much an application is consuming of the cluster on a big time frame. You can do it in a low time frame, but you can do it on a big time frame. And what we do right now, we track billing costs we know how much the cluster is spending, we know how much the full set of applications is scaling, is spending, but we know how much a country is spending, but we don't have a way to track inside each country which application is spending more than it should or not. That's what we're working at the moment. But we have metrics that are being collected we tag every machine that we have. We know how much load is being consumed by each namespace, by each country. But we're figuring out a way of tracking how much a specific application inside a specific namespace is.
If it's location oriented, I mean, if it's per country, so can't we do the same optimization across the country of, I mean, each services and how to maybe optimize, or it's like that difficult or that tough?
By a country we can do it, but we don't know which service at the moment is spending more than how much is spending, because, for example, if you get a merchant that does a big promotion and that gets converted into sales in our Jumia Mall, and that transaction is converted into an actual transaction on JumiaPay, and you have a big burst of sales and payments on JumiaPay, that easily in 10 or 15 minutes could go from last year's 10 pods to 50 pods. Okay, and spin out 2 additional nodes on the cluster so it can handle all the load. And then after 15 minutes the pods die, and you had a trace that pod was consuming something, but you don't know how much of it you did. That's what the problem we're trying to solve at the moment. We have some solutions in the pipeline, but we're POCing them as we speak.
Okay, maybe back to the challenges and the part that we are talking about. The challenges of maybe Phoenix. So while we have a mutable infrastructure, like how much does it take, to do the rotation for the entire cluster?
You mean when the cluster, when we do one update on the cluster?
Yeah, because we have a challenges while we have like a code base.
Yeah. On production, it's taking 17 minutes.
17.
Yeah, 17.
17.
Yeah, a full cluster.
Okay.
So our Pay cluster at the moment should have like 34 machines, probably. On Black Fridays it has 60. It scales up to 60. So it takes on 60. It should increase by 1 or 2 minutes to do it, because our suite of Python Bash is taking into account which applications are on safe nodes, so it's tracking which applications are on the new nodes, and if the nodes that are left already have those applications and no others, it kills them. Right. So it's not an increase, steady increase of time. It's like it doesn't duplicate. It just takes 1 or 2 minutes more.
Well, this caused some challenges, or downtime?
There was a lot of challenges in doing that, but
can you tell us like 1 or 2?
Before, that's why we went to templating, because we didn't have node groups, we didn't know which applications are running on which nodes, we didn't assign them at will. When we started templating them, it became easier. That's why we went to templating infrastructure. It became a lot easier because we could count on that the previous deployment was done in a certain way, and we are safe to kill like 3 or 4 clusters because this node group already has all the applications on the new version of the infrastructure, so we can kill those 4 nodes immediately and take them out of production. That was one of the challenges that we had, to find out if to decrease the time of deployment. If we did that and we were not sure that the 4 nodes weren't running any applications that were on the new clusters, if we kill them, we have downtime basically.
I get it. Thank you. So maybe.
Hi. Yes.
How do you think that will contribute to a culture of continuous experimentation, very fast, very fast?
Well, the proof is on the pudding. It's like basically, if we try and we fail, we get better. Okay? And the trick is to do it slowly, and the trick is to do it with canary deployments. We insert chaos engineering as well, so we know our fails are, because we're gonna fail. Everyone fails. The important thing is that we build the controls to fail fast and hold back as fast as possible. And if we have,
From mistakes as well, right?
yeah, huh? Yeah, and learn from mistakes as well. Yeah, exactly. Yeah. Anyone else? Oh.
So one thing that still intrigues me is that one classical problem that we still have nowadays is that development teams are highly specialized in this result and just chipping
application teams what they are building. But after that, a classical problem is that they still don't have the full visibility how the applications are running in life. With all of these changes that you did, how do you think we can impact the development teams, giving them more awareness of what is happening in life, and making them grow in terms of guaranteeing their applications are the best as possible in production?
Well, we inserted a lot of instrumentation on this, and what we're missing is exactly the previous question. We're missing a full dashboard and an interactive one that allows for developers to see how Kubernetes releases things, how's the flow, how it does things, because for everyone that's not managed the Kubernetes cluster, it's like black magic. Okay, you say on Jenkins, you deploy it, and that creates 3 replicas, it creates a service, it moves traffic into the new applications, it sees if the application is up and running or not, it kills it if it's not, it rollbacks automatically. But what our developers are doing right now is they're doing this tracking through Kibana, they're doing this tracking through Grafana, which is not a good solution at the moment. But as I said, it's 8 months. We're working on dashboards. We're working on empowering developers. We are working on them for them to focus on what matters. So they are not worried about building. So they are not worried about deploying. So they can focus on code. Because if they do better code, it's better for us because the pipelines don't break. And basically, we want to give them access to every metric possible. We want to give them access to every information possible. But that's how the DevOps approach is going to work, because we need to work close with developers. We need them to tell us, like, I need this, I need that, and tell me what you need from my side so I can get better. And we will do it in time, but we will do it slowly, but we will do it.
Very much.
Anyone else?
Okay. I want to ask about how you handle the database backups and the database migrations. Did you automate this process? Or, yeah.
That process is like the gray area, where we, as SREs and developers, work very closely together. Honestly, the migrations are done by the most experienced people to do migrations are the software developers, and we leave most of that responsibility to them. What we basically do is, one of the approaches is, because we're using Kubernetes on a destructive migration, for example, we have in process of building an efficient process to ensure that it doesn't depend on the developer code of the migration, that we control for every failure that can happen. But at the moment, we use like Flyway, for example, to do that. We build it on a pod runs the migration. When the application runs, the migration is done. Okay, so we don't have conflicted migrations, so we don't have pods at the same time trying to do the same migration, or we don't want the developer to have the care to say, look, let me check if the migration was done or not. Okay, we are building towards this. We don't have a complete solution. There are some teams that do this very well because they use like Flyway, for example. We still have development teams doing migrations manually, and that's what we want to get rid of. want to start building a process where that's the practice, not to have problems in migrations and not depending on the developer's ability to do them. Anyone else?
What do you think about DevOps and Meetup?
Well, DevOps will be about orchestrating the orchestrations for me. Because actually we have around 10 clusters on production right at the moment. We have the same for staging. We have the development ones. People want sandbox clusters. And one issue that we have of not allowing developers to code and to deploy into a cluster of their own is basically because it's very hard to manage. If we find a tool that monitors multiple clusters well, not as Rancher, for example, which it does it very badly, but if we find an orchestrator of orchestrations, that will be great. That's the step. And that's in terms of tech. In terms of culture, because it's more of a culture than a tech position, is basically empowering developers. It's always been the same. So the only difference is I think it's going to tend more to, instead of teaching developers how to use partially the stack of SREs, it's empower them with tools. It's tooling and automation and giving them the tools to do things seamlessly. I want an app, I write a command, an app is born, basically. And that should, I think for me, that's where the culture is going, and it's how it's going to work. Because everyone knows that the Spotify model doesn't scale due to people in tech are not cheap. So if you buy an SRE for every dev, it's just impossible. So it will take a lot of time in culture, building the culture, speaking with the devs, get directly, not get confrontive. Don't see it as a challenge, not a problem. Okay, listening, trying to fix, and stop with it works on my machine, so it should be fine. Yeah.
Maybe if I got my second question, because you were telling that SRE for empowering developers.
Yeah.
So what we have in Jumia, like we have that kind of self-contained tools where we have many specialties for the same business, for the deliveries and the clients and so on. So we have like SRE team member inside each team, or how we organize this structure?
No, SRE inside each team it solves one problem, but it creates multiple ones. It solves the problem of every dev has the attention of an SRE, it builds things faster, but it creates silos. So you will need one, you will need two, because that person has to go on vacation. So you need two SREs. Doing the same tools, doing the same buildings, doing the same deployments for the same applications. If you have them separately, once something happens and you create silos of knowledge, and as a developer, you should, if you go full stack, you should learn at least a little bit of every backend, front-end, middleware, whatever you use at the moment. But if you go SRE, you should know a little bit of everything. But if that application only uses, let's say, Nest, or only uses other framework that you want, that person is gonna get a silo, because you don't know how to tell him how to do the shard, how to do the deployments, how to do the Docker file, how to build it. You couldn't troubleshoot the pipelines because you never worked on it, and it will take time for that person to learn. I think the SRE model for Google works better because you built an underlying structure of the SREs that are full stack in terms of the development teams. They understand every development team because they template everything, they build things to be scalable, they build things to be reusable, they build things to be automated and used by developers. So for me, the SRE model for Google is the best one so far. But I'm still expecting for like 3 or 4 years for someone to come with something new, but they don't. So. Any more questions? Thank you.
Well, thank you, Alex. So that's it. So thank you for coming, and I hope that I can see you all next time. We will do like some frequent, very frequent actually meetups later on. So we can have all of you. Maybe some of you will be maybe working with us at Jumia. So at the end, thank you all.